Synchronization is one of the most important things that we have to get our handle on when we are doing test automation. When anyone ever brings me over at their desk and says, these tests don't work, or these tests are intermittent, or these tests work on my machine but not on his machine, these tests work on my machine but not on the build machine, the first thing I'm looking for are synchronization problems, because they lead to test intermittency, where your test runs fine once, you run it again, it doesn't work. You run it as part of the continuous integration process, where it runs in a different order, your test doesn't work. Where your tests are too slow. Sometimes when your tests are too slow, it means that you have too many implicit waits. You're not synchronizing on the right things. You're waiting too long for things to happen. You get false positives or false negatives because you're waiting on the wrong thing and something comes through. Or your test, you eventually discover, doesn't actually test for what you think it does. And generally, a lot of the moaning about the test tools on the projects tends not to be the tool itself, or the root cause is not the tool itself, it's the use of the tool, and often the use of the tool in terms of how we synchronize. So what we're going to look for in this section are how to use the WebDriverWait functionality and all the expected conditions and functionality around that to improve the synchronization on our projects. So let's start with the simplest example of why you need this. You've already seen this example in action, but let's do it again because we're going to build on this over this session. So I want you to go to compendiumdev.co.uk/basic_ajax.html. From the first combo, select Server. From the second combo, select Java. Then click the Code in it button and assert that on the loaded page, the item with _value language _ID has a text of 23. Now that shouldn't work because we need some synchronization points. Then what I want you to do is breakpoint it and step through it and get it to work. And identify what synchronization points you think you might need in that test. So I'm just going to show you the page. So remember, we're going to go off to compendiumdev.co.uk/selenium/basic_ajax.html. We're going to select Server. You see that little Ajax. Then we're going to select Java. That little Ajax is why it's not going to work, remember. Click Code in it. Then check for this field having the text 23. Do that exercise now. It shouldn't take you very long now that you know what you're doing. And then a lot of our exercises afterwards are going to build on the work that we've just done here. And when you ran the test, did it fail? I hope so, because that was the whole point of that exercise. That exercise was designed to say, let's create a failing test. So I'm going to show you mine. Hopefully it's the same as yours. We go to the page, we select the first combo, we immediately select the second combo to select Java, we submit the form, then we check for that value. This would work fine if I debug through it step by step, but when I run it, it fails. There we go, failing test. And what did it fail on? Hopefully the same reason as yours, unable to locate the element. And let's look in the debug. Unable to locate this element, the Java. Because we know, we clicked Server, the little Ajax GIF comes up, we ignore that and look for Java straight away. It hasn't done the Ajax call, it hasn't loaded that in. Therefore the test fails. So let's look at it in debug mode. And I am labouring the point here. Hopefully you'll see why in just a second. So we have our browser open. So our next step is to find the element. Great. Now let's click the first combo. Great, there's the little GIF. We no longer have any synchronization points because we are manually synchronizing through this. So let's find the next combo. Great. Let's find the language we're looking for and click on it. Great. Now let's click the Code in It button. Page is loaded. Now that change there, when I was asking you to come up with what are the potential risks for synchronization, that's the other risk. Loading that new page adds a potential risk of synchronization issues in our test. So we may need another synchronization point in there. Click through, assert, job done, the test passed, it works on my machine, works in debug mode. I have no idea why it's failing in continuous integration. It's because we haven't got the synchronization points. So this is it, the step through heuristic. If it works when I step through, but not when I run it, then I probably have a synchronization problem. This is also known as, well, it works on my machine and it works in this browser. So now for the rest of the session we're going to figure out how to fix that so it never ever happens to you in the real world. Yeah, right. So our savior is the WebDriverWait. Now you've already used the WebDriverWait and you've already used the expected conditions. This section we're going to go over that knowledge, we're going to reinforce it, we're going to go into it in a bit more detail. Previously we've asked you to use it, now we're going to ask you to understand it. So you've already seen that we create a new WebDriverWait, passing in a driver and giving it the timeout time. Now you already know that there's two parts to the constructor. We can either construct it with just a timeout in seconds, or we can change the polling time that is in use. So here you can see two tests here. One which times out after 10 seconds, one which times out after 10 seconds, but polls for the condition is this title HTML form elements every 50 milliseconds. And what does the WebDriverWait do if it times out? It throws a timeout exception. Remember, we always want to make sure that the exceptions that we pull in are the correct ones for WebDriver. So I suspect, because this is the way that I've shown you, in your tests you've done things like new WebDriverWait, driver 10 until, then add the expected conditions in. And I've done it that way to make it easy and obvious for you to start with. So let's look at how we can tidy this up. So you already know that the new WebDriverWait returns a WebDriverWait object. That's what it does. That's what you're using. So there's no reason at all that we can't just stick that in a variable and use that throughout our test. So here, this is the same two tests, but I've refactored it slightly to show you some slightly different ways of doing this. So in the @before method, I am storing up the WebDriverWait in a variable so that we can reuse it. So my tests become a little bit more readable. I can say wait until expected conditions title is HTML form element. And in the previous test, having waited on it, I checked the title text. I don't need to do that, remember, because the wait itself, if we get a timeout exception, this assert has failed. Therefore, I don't need that assert in here. Now, the other thing that we can do, I've shown you the expected conditions like this with the static completion to make it easy for you to understand the scope of what the expected conditions are. But we don't need to do it that way. I can do a static import on this. So that now I can say wait until the title is HTML form elements. And what it's done up here in the static import, we have the expected conditions dot title is. We've imported this method into our test to make it more readable. So instead of the full test here with an extra assert with all the words in here with this long value, we can make it read a little bit better if we just do a little bit of refactoring work. Now I'm going to point these things out as we go through this session and reinforce it at the end. But I just want you to be aware that as we go through the course, I am showing you things to try and make it easier for you to get a handle on it, but not necessarily the easiest way of writing it when you go live, not necessarily the best way, the tidiest way. So I'm going to try and tidy that up so that you know what you can refactor to. So our basic principles here are, if we've already waited for it, we don't need to reassert it. We can store up the wait and reuse it as we go through, and we can statically import the expected conditions to make our test read better. So this exercise is to fix this failing test. Use all the knowledge that you have, add the necessary expected conditions, and fix this failing test. Now remember, we have a bunch of expected conditions that we can use. And they're all here listed nice and easy from code completion. It's one of the reasons that I show you this way, because it's a lot easier to get your head around. So look at these different expected conditions, figure out which ones are most appropriate to help you synchronize. And remember, when we come back in the examples, I'm going to show you multiple expected conditions that I've used in order to synchronize on that page. If you pick one, that's fine. See how many you can come up with. And remember, we identified two risks: the AJAX call, so figure out a way of synchronizing on that, and then the page load. Figure out a synchronization point for that page load. So how did you do? Well, I have 5 different examples here. One of them should never be copied. Okay? So here's the first example. This is how you make a failing test pass. What you do is you wrap it in a try-catch block and assert that something has gone wrong. There you go. That test will pass. Now we mock and we laugh, but we've seen these things in production code bases. So we want to make sure we never ever wrap our tests around an exception such that when the test fails, we catch the exception and report that it's true. Okay, so the other way. Now because I have written 4 different tests here, I have refactored it and chunked the code into methods. So each of these tests look like the following. They say start the browser and select server, because that's the common thing they all do. Then I have a synchronization point, and this makes clear what the synchronization point is. And then I select the Java, submit the form, and check the results. And this has an embedded synchronization point. So let's have a quick look. To start the browser and select server basically just says go off to the page and select the combo box. We know that. That's easy. So the first thing that I'm doing is I am waiting until the invisibility of the element is located, i.e. waiting for the AJAX image to be invisible, waiting for that image to go away. Now there's a potential risk that we do this check before the image is even there, therefore it's still invisible, then it comes through, then we fail. Potential risk around that, tiny, seems to work fine, so I'm going to leave that, I'm going to count that as a valid way, but the reason I'm pointing out is every decision we make, we have to understand what risks that imposes. What are the constraints we've just introduced? Is that the most risk-free way of doing it? So I'm assuming that there is some risk associated with that one. That's not the most risk-free, but it's a valid way of doing it. We may reduce the intermittency, but make it even harder to pinpoint intermittency later on. So the next way I've done it is by checking for the presence of an element. And in this case, it's the element that I want to click. So I'm doing a WebDriverWait until presence of element located for this one. And then we submit the form and check the result. So the next one is I'm waiting for the option to be visible. Not necessarily present, but actually visible. So there's a difference there. One is it in the DOM? One is it in the DOM and visible? Great, they're slightly different. And the next one, is it in the DOM, visible, and clickable? So this is kind of the ultimate one. The thing that I need is actually there, and it is clickable. Now if you drop down into the code, you'll see the differences that are associated with these methods. And it's quite an interesting exercise to do so that you understand what each of these expected conditions does. So I have the 4 different examples there, and remember my end result for the page synchronization, I have always synchronized on title. For this particular page, it's a flat HTML page. Once it's loaded, it's really come back in the state where I can access it, and all I'm really doing at this point is checking that the correct page has loaded. By the title, I'm checking that the correct page has loaded. If it was a more complicated page, I may need to wait for specific things on that page being available. I mean, you could have chosen to wait until this particular element was present or visible on the page. That would have been an alternative, perfectly valid synchronization point to use in this test. I mean, this is really the basics. For a lot of production code and a lot of automated testers, they don't go beyond this. This is as far as a lot of people go with their synchronization. They use WebDriverWait, they use the built-in expected conditions, they use implicit waits in page objects, and that's pretty much it. We are going to take this further and learn how to use custom expected conditions, but if this is all you did, there are some teams where you would be absolutely fine. Okay, now it's time to learn how to create our own expected conditions. Now you've already seen the expected conditions class, and you've used them. We can start doing our own. Now we would want to do this when the expected conditions class does not have what you need, when it simply doesn't do what you want. If you want to make your test read well for your own scenarios, then you might want to create your own expected condition to read well under the particular circumstances that you've got. If you want to pass in additional values so that that apply method can act on them, then you'll need to figure out a different way of doing that. And the way that we do that is by creating our own custom expected condition. And I'm going to show you a couple of ways to do that. One as a separate named class, one as an anonymous class, and one as an anonymous class wrapped with a method. And clearly we can do the named class wrapped in a method as well. But it's essentially named class, anonymous class, whichever, wrapped in a method. And we'll look at the different ways and pros and cons of doing each. So this is showing a named class. And the named class is the select contains text class. And you can see it in use here. So when I'm using a named class, I have to say new class name and then the constructor in the until, which is different from what you saw with the expected conditions. Expected conditions is a method call. So expected conditions dot title is. That's a static method that we're calling. So that's the class wrapped in method approach. What you're seeing here is the named class itself approach. And if it's a named class, you have to instantiate it. Now you could choose to make it a factory method on that class so you don't have to do new in front, but you're still essentially constructing a new class to do it. So benefits for doing this. We can create our own constructors. So if you're using an anonymous class, you can't create the constructor, so you can't do select contains text and then put the arguments in, and that's why you wrap it with a method. But let's have a quick look at this custom. So here, when we see this in the code, this will make more sense. But I've made this a private class because it's a class within one of the tests itself. This is typically when you'd use an anonymous class, but I've made it a named class within that test itself. And it's implementing an expected condition that returns a Boolean. Now we're going to cover this in more detail later on, but an expected condition, you've seen it return, if you used ExpectedConditions dot title is, then it returns a Boolean. If you used expected condition element is visible, then it returns the web element. So the expected condition itself can return a Boolean or a web element or pretty much anything you want. An expected condition, if we put it in as the generic there, can return whatever we want. So here, one of the benefits of a named class is that we've got a constructor. So it's using it the same way we normally would. We've got the constructors in there, then we've got field variables that we can use in our apply method. This is all very simple. This is what you would do just straight from using Java without much additional knowledge. We have to override the apply method. Whichever approach we take, we always have to create our own apply method, because that is what is called by the WebDriverWait. So we pass in our expected condition into WebDriverWait. WebDriverWait just knows that it is an object that implements the interface the expected condition has and calls the apply method on that object. So we have to make sure we implement that apply method. And in the code you'll see I've also implemented the toString method so that it can render it through under different circumstances. And you can see that the apply method, when it's an expected condition, because we're implementing expected condition, the apply method always has a WebDriver passed in as the argument. And that's how we access the WebDriver. Because you can see we've created a class select contains text. There's no mention of WebDriver in the constructor. And if I jump back a slide here, you can see that the only place that the driver is mentioned is in the WebDriverWait. It's not mentioned as being passed into the select contains text class. That's because when WebDriverWait calls the apply method, it passes in the driver for us. That's how we get the driver to act on in our apply method. So that's in the slides. I'm trying to go over this fairly quickly so that when we drop down the code we can do it in more detail. So you will see this twice. You'll see it here in the slide and in the code. So then we also have the ability to create an ad hoc wait, an inline wait. And this is done through an anonymous class. So here, instead of new WebDriver wait until expected condition or new WebDriver wait until new named class, we're doing new WebDriver wait until new expected condition. And by doing it this way, we've created an anonymous class. Because it's a class, we still have to override the apply method, which is what we're doing there. And I'm saying here that this expected condition will return a Boolean. So the apply method is defined as returning a Boolean, and the actual return statement is the Boolean. Now the thing about the inline example here, we cannot create custom constructors. We cannot have a constructor to pass in the any additional information that we want to use for synchronization. So for these very, very simple ad hoc waits that are created within the until block itself, the only thing that we have to synchronize on is the WebDriver that is passed in as part of the apply method. Now we can get around that either by creating a named class or by wrapping these anonymous classes in methods. So let's have a look at that. So here we've got an anonymous class. You can see it in the return new expected condition web element. That block there is the anonymous class, but we've wrapped it in a method, and the method is a private method called option with value displayed, and it is taking a variable called value as a parameter. And you can see that in the body of the anonymous class in the apply method, I'm using that value. So I can actually with an anonymous class, pass values in so long as it's wrapped in a method, and so long as that parameter is declared as final. So final string value in a parameter with the body of that method being an anonymous class, I can then, in the synchronization code, in the apply method, use that value that is passed in. So there's a number of things in there. If I want to pass in the parameters, I either make it a named class or I wrap it in a method. If I don't need any particular parameters and it's really ad hoc, it's really one of a kind, then I might choose to do it as an anonymous class within the actual wait statement itself. So let's have a look at this in code, in context, and it will make a bit more sense then. So let's start by having a look at the ExpectedConditions class, because this is going to be your archetypal custom expected conditions, because that's really all that these expected conditions are. Now we know that they come from the support jar, but the way that we're bringing in Selenium, they're available to us. And you can see that the ExpectedConditions class has these static methods, so you're used to ExpectedConditions.titleIs, and now we can see what this does. It's pretty much what you saw on the slide, so you can see that this method has a parameter called title, which is a final string, and that's how the anonymous class within this is able to use it. We can also see that it's returning an expected condition because it returns this class which returns a boolean. That's what this means, an expected condition which returns a boolean. So this is the wrapper. Then we have the anonymous class which is returned, and this anonymous class is defined as being an expected condition which returns a boolean. You can see that because it's a class, it has its own fields, so we have a current title that we're keeping track of. We have an apply method which, because it's an expected condition, has a driver injected in at the apply method, and we can see that what this anonymous class does in the apply method is say driver.getTitle, store it in the current title, then is this title that was passed in to the method the same as what we have currently got from the title. So it simply returns that boolean value that results from doing that equals. That's how it gets its result. If it's false, it returns false. Then the wait knows to keep coming back based on its polling schedule and apply that. And you can see that it's overridden the toString method to say that when something tries to print out the wait, it'll say title to be current title, and then there's the two values passed into the string format. So title to be this, current title is this. And they're all much the same. So you've seen here one taking the boolean. Let's find one that does a web element. So here's one that does a web element. Again, it's much the same. The only difference is we declare it as web element. It's got a final with a by being passed in as the parameter, so we know that this locator can be used within the anonymous class. The anonymous class itself has an apply method which returns a web element which we're expecting, because that's how the expected condition has been declared, and all this does is return the find element using the locator that was passed into this method. That's where it's used in there, using the driver that gets passed in by the WebDriverWait when it calls the apply, and again it's overridden the string. So these are kind of really good examples for how to build a custom expected condition. And what they've done is they're all static methods. They've been put in a class to make it easier to access. And I think it's worthwhile. I think you probably now have most of the knowledge that you need to walk through this and see what they're doing. And I think that's a useful exercise for you to do, because then you will understand different patterns for writing your own expected conditions, wrapping them up in methods, which is what this does, and you'll get a feel for the functionality that is available to you in the expected conditions and why you might want to write your own. So I have two classes to show you here for custom expected conditions. The first one is the named class. So this is the test pretty much that you saw before. We go to basic Ajax, we click on the first combo, we have to wait. Then we click on the next combo, submit the form, and we're on the correct page. So for the wait for the next combo, I have created a custom expected condition. And so the test reads as new WebDriver wait until new select contains text, and then I'm saying for this particular by with looking for this particular text. So I'm a select identified by this which contains the text Java. So here you can see why it was a private class. It was a private class because it's a class within my test class. Now I would only do this if this is the only place that this class is used. If this select contains text is used in multiple places, then I would move it out into its own class, assuming that I stick with the approach of containing an actual class. Now why might I want to use a class as opposed to a method? Well, I might decide that a class is easier to unit test than a method. I might decide that because then I can call each of these methods in isolation. It might be a little bit easier. Otherwise I have to call the anonymous class that comes through. But that you could test either way. It's pretty much up to you which pattern you fall into. I suspect that most people don't use the named class and use the anonymous class approach, because then you can typically create the anonymous class and you wrap it in a method. Then you basically just abstract that out into another class where you make it static. So you have some sort of factory class essentially, or some sort of provider class that returns these methods. But here the example, because I'm trying to show you the options. I like to try and give people options so that they can experiment with it, weigh up the pros and cons and make their own decisions. So here we are showing you the private class approach. So you can see again, it implements the expected condition for a Boolean. I'm not sure how far in the course to go through this because you don't really need to understand Java generics in order to use them. But this is implementing Java generics. I suggest that you use it, and if you get to the point where you really want to learn more, then read something like Effective Java, the book, which covers generics really, really well, and try and experiment with them. I'm going to do a few examples later on that show a bit more use of the generics, but I'm not going to drive into it in detail, I don't think. If you really want to see it, then leave some comments on Udemy and we'll see if we can cover it in some later exercises and later lectures. But for the moment, understand that this is using something called generics. And what we're doing is we're passing in saying this is going to be a Boolean. And that means that whatever we use here, we have to use here. That's essentially what we're saying. So I can declare this as a Boolean, I can declare this as a WebDriver, I could declare this as a string, I could declare this as a list of web elements, I could declare this as whatever I want, so long as it's the same thing is done here, and so long as that's what I actually return. Because remember that apply simply says, is it a true or a false? Is it a Boolean? In which case that's the value that I'm going to use to return. If not, then it's either an instantiated object or it's null. So if we haven't matched it and we're not using Boolean, we have to return a null. Anything else that we return gets counted as a true. So what else to point out? So here you can see that I have overridden the string method the same way that you saw in the expected conditions. That's a good thing to do if you're creating your own classes. Anyway, just override, and particularly when it's being reused in different places. And is there anything else to draw out at this point? Okay, so let's look at the actual code here. So this is saying we're passing in a by, because a by, like anything else, is just an object. So we can pass them around, and then they're there for reuse. And I'm passing in the string that we need to find. So they become fields in my class, and I can use them in the apply method. The WebDriver, remember, is passed in by the WebDriverWait because we're implementing ExpectedCondition. Later on we'll have a look at other classes where we can pass in whatever we want, but at the moment, because we're dealing with ExpectedCondition, we will receive a WebDriver in our apply method. So we have to use this constructor, this signature. Then I find the element using the by. I've called it combo because I'm expecting it to be a combo, a select. Then, but theoretically, based on this text, it doesn't really need to be. However, we then, given that, look underneath it for tags that are options using find elements. Then I iterate through those web elements and say, do any of these web elements have the text that I'm looking for? If they do, return true. Otherwise, return false. Then it will go back to the WebDriverWait, sit for its polling time, then come back and run the apply method again. So that's pretty simple, but that's a little bit verbose because we've made it a private class. So let's have a look at the anonymous approach. So here, you can see the test. It's very much the same test. This is all the setup. Go to the page, click the combo box. But here I'm using the anonymous class directly. Let me open this so IntelliJ doesn't obscure any details. Here I'm using the anonymous class directly. So again, this is new WebDriverWait until, and this is how I'm constructing my anonymous class. So it is an anonymous class that is, so it is a new ExpectedCondition that returns a Boolean. So you'd expect the apply to be returning a Boolean, which it does. It's an ExpectedCondition, so it has a WebDriver being passed in. Because it's an anonymous class directly within the until, all I can rely on in my synchronization method, the apply method, is the use of the WebDriver. So you can see here that I have fewer options. I'm looking for a particular option in the dropdown, but I have had to hard code that into my text. Other than that, this is basically the same mechanism. It's a Boolean, it does a CSS selector for this particular value. So sometimes I use this if it's really a one-off. It's only ever going to be done here. I can extract it out into a private method on the class to encapsulate this whole functionality and say, wait for Java option to be available, possibly. But this is a one-off. Anytime I want more flexibility, more reuse, that's when I wrap it in methods, or if I want to make it really explicitly clear. Your coding style will differ. There are some people who always do WebDriverWait until then have a method in here that is taking parameters. It's different types of coding styles. I kind of adopt whatever is appropriate for me. You can choose what one works best for you. So also down the bottom here you can see I have a test which is doing exactly that. So instead of the anonymous function being inline, I have wrapped the anonymous function in a method called option with value displayed. So here you can see option value 23 all hard coded. Here you can see that the method is called wait until option with value displayed, and I'm passing in the value. Therefore you can probably guess what this method looks like. It's got a final string because I want to use this value text within the apply method. It returns an ExpectedCondition. Here I am returning a web element. So when it finds an option with value that is displayed, with the value is 23, then it will return that web element. So it does basically the same check that we did up above. WebDriver.findElement, CSS selector for this particular option, and return that web element. So if it can't find anything, it will return null. Because remember, apply will capture the element not found exceptions. Element not found exceptions are not thrown, therefore we can safely do this and know that a null will be sent back. And when it is found, we can actually use it in the test. So this is a good pattern to remember, because one of the things we want to do with the WebDriver wait is wait for the thing, then use it. So we don't want to have to go through the hassle of waiting for the thing, then finding it, then using it. Where possible, wait for it, have it returned, then just use it. That's what this pattern is designed to illustrate. It's designed to illustrate two things: the returning of the web element so it can be used, and the wrapping of an anonymous method, an anonymous class with a method which takes a parameter. So hopefully that makes that a little bit clearer. Any questions, just ask on the Udemy. Okay, in this video I just want to have a quick code walkthrough of the custom expected conditions and how the WebDriver wait works. Because this is probably the most complicated thing that we're ever going to have to deal with in WebDriver. And I understand that when people first look at this, they get a little bit confused about how the code works. So I get asked questions about this on the courses, when I do them face to face. We get a lot of emails asking questions about it. So I just want to go through the code step by step and see if we can make this a little bit more clear for people who are first coming to it. So this is our basic construct. We have a new WebDriver wait, then we say wait until, and then we give it an expected condition. Now this is basically an object which has an apply method on it. That's really all that this is. So we pass an object which has an apply method on it into the until statement, and the until statement does all the work of looping, checking the return value from executing the apply statement, and calculating the timeout for us. So I'm just going to have a quick look at the expected condition. Now I'm using the ExpectedConditions class, this static class that comes in the support class, because this has a lot of good examples of how to create expected conditions. So have a quick look at the title is. So title is method, basically returns a new expected condition. So this is basically an anonymous class which has an apply method. This is really what's important. What we're saying is here, this is an expected condition that returns a boolean, and it implements an apply class and a toString. That's really it. And this is really all that's important for the until method, the apply method, because this is what the until method is going to call. And because it's a WebDriver wait, it takes a driver, so that we've got access to the driver. Anything that we want else to have access to, like here the title, we pass in through the constructor, or pass in and make available into the class here. So the title is available to this method because it's being constructed with it in here, and the driver is available because it gets passed in through the apply method. Now if I have a look back here, you can see that we create a new WebDriver wait and we give it a driver. So if I have a quick look at the constructor in here, we can see that the new WebDriver wait is calling another local constructor here. And what this constructor does is, given a driver and a clock, it calls the super constructor on the FluentWait and passes in the WebDriver as a thing called input. So the FluentWait in the until method has access to the WebDriver through this input variable. So if I jump back to WebDriver wait, we'll jump back to test, we're saying we have a WebDriver wait object, and we want to call the until method on that object with the expected condition. And this expected condition implements the apply method. So let's jump into the until, because this is where the magic really happens. Now it looks relatively complicated because it's all using Java generics, but we know what the basic things are here, so we don't really have to worry about this too much. We know that this is the expected condition object that we passed in, which we know implements an apply method. So we can see here that what happens is we have essentially an infinite loop. It says while true, so this whole section of code in here is really an infinite loop, and it will end when we return from it, or we throw a timeout exception, or possibly throw a WebDriver exception. But these are unchecked exceptions, so we don't have to catch them. And essentially we think about it as this is looping round. First thing it does in the loop is it tries to execute the apply method. If the apply method throws an exception, then that is caught and stored, ready to be propagated through here if we've run out of time. But the basic process is, at each point in the loop, we come in, we try and execute the apply method. If the apply method actually returns a value, and if that value is true, then we return it because it's the end of the iteration, it's the end of the expected condition. Or if that value is not null, then we return it because it's the end of the expected condition. If the value is an exception, then we catch it. Then we come down to the next step. And the next step is basically saying, have we run out of time? Because the wait for is a timeout process. So it basically says, if we've come to the end of our time, then throw a timeout exception, but add in the last exception that was thrown by our apply method. Then if we haven't executed here with a return value, and we haven't executed here with a timeout, then we pause for a little bit of time, and then we come back and execute the loop again. And remember, the first thing we do in executing the loop is to execute the apply method on our expected condition. And that's where this comes in. This is the expected condition that's been returned by our ExpectedConditions class. So we can see here in the FluentWait that the input is passed into the apply method, which we know is a WebDriver. That's where the WebDriver comes from. Anything else that we want to be available to our expected condition, we pass in either when we create it or in our class. Say we've created a class for the expected condition, then we pass it in through the constructor. Then you can see that the apply method on this has access to the WebDriver because it's passed in, and it has access to anything that we passed in through the constructor because it's part of this class or part of this object. Now there's not a lot of magic in there. All we really have to get in our heads is that when we create an expected condition, we have to implement an apply method. Here, this anonymous class is implementing an apply method as part of creating an expected condition. Our class that we created in the custom expected condition is implementing the expected condition interface. So this is using interfaces. It will return a boolean, so this is using generics. So if you want to look things up, look up interfaces, because that's what select contains text is doing. It's implementing an expected condition interface, and it's using a generic to say it returns a boolean. That's all important when constructing the apply method, and it's the apply method that we have to create in order to work the magic. So after all that, it's your turn. So we've got two exercises here. The first one is to use the basic_ajax.html page that you've seen throughout those exercises. Create a WebDriverWait with an inline expected condition, which returns a web element, not a boolean. We want to use a web element. Then, for the web element that you're waiting on, assert on the text. So typically I would wait on the option 23, the Java, then assert that that option 23 does actually have the text Java. The other thing we're going to do is to create our own custom expected condition called title does not contain. It will take a string as a parameter and use the /selenium/basic_redirect.html page. I'm just going to show you that. So this is the redirect page. We've got two redirects. I want you to test both. And essentially I want to make sure you click on it and are redirected. I should really have clicked on the one that takes 2 seconds. There you go. This one, click on this, and in 2 seconds I'm redirected to that. So you can see we're going to have to assert on a couple of things, and there's a wait. You get to choose how to click and what to wait for to make your test demonstrate that these things redirect. And I hope you chose to experiment around there. Certainly in the examples I've got, the second exercise I did that the 3 different ways. So let's see what you did. So I'm just going to run the test so you know that they do actually work. So I hope no one decided to wait for a time period. Let's have a look at ours. So all those tests passed. So the first one was an anonymous class that returns an web element. So you saw so many examples of this that I really can't imagine that this was too hard for you, but let's walk through. Normal test, go to the page, click on the value, then WebDriverWait until a new expected condition that returns a web element. We override the apply method, which returns a web element. We have the WebDriver to work with, so I have hard coded in the selector. I'm returning the web element. If the web element is displayed, then I return the web element, otherwise I return null. Then I can click on that web element. So hopefully you did something very similar. Then I can check, this was the important thing, this was the assert that that web element has the correct text. So hopefully you did something very similar to that. Then for the custom expected condition, so I have done that with a private class as before. So you've seen we go to the basic redirect, I find the element, go to basic, delay, go to basic, I click on that, then I wait for a new title does not contain redirects, and that is implemented just as a private class. I'm returning a string so that I can assert on it, because we want to wait for the thing, then use the thing. And here the only thing I want to use it for is an assert, so I'm going to return the new title, the title that does not contain the redirects. And there's nothing unusual in here except I store the title that comes in the constructor, so the excludes value. Then in the apply I check for the current title that the WebDriver has, does it contain the value? If it does, return null because we haven't found it yet, otherwise return the new title, and then that can be used as the string in the test. So here this is using a private method, and this time it's a private method wrapping the private class. The only thing that's different then in this test is that I have assigned the wait to a variable so that my test says wait until title does not contain f, because it's a function, redirects. So that's a little bit tidier. Then where you got the anonymous class, AC, wrapped in a method. Again, the wait is put into a variable, so I say wait until title does not contain redirects. And in this particular circumstance, you can see that this is probably the tidiest approach. This is probably the approach that you would want to take, where you have the anonymous class wrapped in a private method with the wait declared in a variable. This is giving you the tidiest code. It's very simple, it's very easy to maintain. There's no superfluous stuff. We don't need to maintain other classes. This seems like the best approach for that. So hopefully yours was something similar. There was nothing new there from all the lectures that you saw, but it was good for you to have a chance to do that. Now as you implement more and more tests, you're going to have ever more chance to implement new WebDriver waits, because that's pretty much the synchronization approach that you're going to use. This is the explicit wait, and it's so important to our tests. So some more nuances around WebDriverWait. WebDriverWait is built on top of a class called FluentWait. That gives us the ability to construct a WebDriverWait in a way that is more readable. So you already saw us do new WebDriverWait driver, then timeout. We have some additional methods. I can say polling every to override that polling instead of putting it in the constructor. I can say ignoring to ignore additional exceptions. We know that the element not found exception is ignored, but we can ignore other exceptions. So if I want to ignore a single exception, I can add it in through ignoring. I can change the timeout to time with the with timeout. I can add a message that happens on timeout, and I can ignore a bunch of exceptions. And so this allows us a different way to create WebDriver waits. Let me show you an example. So here we go. So here I've gone new WebDriver wait for a driver with a timeout time of 1 second, where we poll every 100 milliseconds. See how much more readable that is. Ignoring an illegal state exception class. With timeout 5 timeout unit seconds, so I've overridden the timeout that's in there. With a message, we'll wait 5 seconds. This will be shown in the timeout message itself. And then my until block, I've got an anonymous class in there, and that anonymous class is simply there for the purpose of this example, where it actually throws an illegal state exception. So given this code, what should we expect to see? Well, we should expect to see it wait for 5 seconds, because that apply function always throws an illegal state exception every 100 milliseconds. Therefore, it never returns a Boolean true. Therefore, it never comes out of its loop except when it times out after 5 seconds. So it's fairly simple, but I'm going to show you that in code in just a second. So I'm going to show you the Fluent interface in code. Now I've just run the test. I didn't see the point in making you sit through that, because all the test does is go to the Compendium Dev website, then run the wait that you saw in the slides, which basically waits for 5 seconds, then checks that more than 5 seconds has passed. So there are some uses for this. You get a timeout message that you didn't see before. You have a little bit more flexibility about the ignoring of different conditions that might happen in your reply. So you don't really have to wrap your reply with try catch. But chances are you probably would. How often you're going to use this interface? I don't know. I rarely use it. If I need this kind of flexibility, chances are I will be trying to do something that I don't need the WebDriver wait for, and I need the Fluent wait for. Because remember, this is built on top of a class called FluentWait that we will look at later. And here we are waiting for something completely unrelated to the WebDriver. That's typically when I use this type of flexibility. But it's worth being aware that this stuff is here. WebDriverWait is built on FluentWait. It has this style of interface that lets you customize in more fluent writing style. So now it's time to look at FluentWait. FluentWait is the class that underpins the WebDriverWait and is there to give you the additional flexibility when you need it. Right, this is there to support you. So you have seen that WebDriverWait extends FluentWait. So everything that you've seen is really a FluentWait under the covers. I'm going to, when we start looking at the code, drop down at the code and you'll see exactly that WebDriverWait is a very thin class. The main differences between WebDriverWait and FluentWait. FluentWait can apply to anything. Most of the examples you're going to see are in context with WebDriver, but they don't need to be. Right? We don't need to wait on a web element. We can be using anything. We could be dealing with string or time or files or anything. It's a generic wait class. WebDriverWait only applies to WebDriver because, again, when we look at the code, you'll see that WebDriverWait extends FluentWait for a WebDriver. That's what it's for. So here's a quick example out of context. You can see here that I'm doing a FluentWait for a web element. So FluentWait here is going to act on a web element, not a WebDriver. It's a web element that's going to be passed into the until function. So you can see here that I have a web element called countdown. I'm passing it in to this new FluentWait web element. I'm configuring the wait fluently with a 10-second timeout, polling every 100 milliseconds. And then in the until block, you can see I'm creating a new function directly instead of an expected condition, a function which is going to take a web element in the apply method and return a boolean. This is showing you all the different aspects that you will probably need if you want to do things more flexibly with your waiting classes. People tend not to go this far. Right? A lot of people will just stick with the WebDriver wait. They'll stick with custom expected conditions. They very rarely have to go down to fluent waits, but they can offer a high degree of flexibility and elegance, which is why we're trying to at least make you aware that this thing exists. Because a lot of the time with automation, you just have to be aware that it exists. At some point you're going to encounter a problem that the stuff that you've been doing doesn't handle, and that's when you're going to drop into something even more useful, like the fluent wait. So let's drop into the code. Now you can see here I've already run the 3 tests that I've got here in the example. Now this first test basically says I'm going to use a fluent wait, and this time it's using a WebDriver. So this is going to be equivalent to a WebDriver wait. I'm going to show you the two in comparison so you can see how equivalent they are. So here I'm saying all the generics are going to be on a WebDriver wait. I pass in the driver so that it's available. Because fluent wait doesn't have the timeout in the constructor, I have to use the fluent style, so I have to say with timeout 10 seconds, polling every 100 seconds. These, remember, are covered either with the constructor or by the defaults in the WebDriver wait. And I'm ignoring a not found exception because that's what we have to do when using fluent wait as opposed to WebDriver wait. Then I just do a normal wait, but the test is actually unimportant. What's important is the usage that you can see here. So in comparison, this is what the WebDriver wait is. See, I've got a WebDriver wait. Now, this time I have done a WebDriver wait in front of it. I'm casting the construction of a WebDriver wait to a WebDriver wait. Why am I doing that? Because the polling every method, which is coming from WebDriver wait, actually comes directly from fluent wait, so it returns a fluent wait. This polling every is not returning, well, it is returning the WebDriver wait, but it's returning it as a fluent wait. Therefore I have to cast this. We're going to look in the code in just a second. And then I've done a wait ignoring not found exception. Didn't really need to do that because that's already part of WebDriver wait. This really is all that's required to make it equivalent to the fluent wait that's above. Now here, as an example of fluent wait, not using WebDriver at all. This doesn't use WebDriver in the slightest. So this is basically saying I want a new fluent wait which will deal with a long in the until method. I'm going to start with a long, which is the start time that we got up here. I want it to time out in 7 seconds, polling every 50 seconds. Then I want to wait until, so here I've put the wait into a variable. You can see it's a fluent wait that works on a long. Then in the until function, all I do is get the current time, compare it with the time that we passed in. When the new time is 4 seconds above the start time, we return the current time. This is an object therefore it's not null, therefore the loop stops. When we haven't matched it, I simply return null, because remember, the until method says if it's a null, keep going. Then I print out a difference. So the Fluent wait allows us to wait on anything. And I have just picked an example here for a long, but this could be anything that you want to do. Fluent wait is a very flexible class that you have if you are using Selenium. So let's drop down into the actual implementation detail. Let's start with WebDriverWait first, because you've seen that. Now remember, we have some help on WebDriverWait, so that when you're looking at it you can see, but that's actually not the help on WebDriverWait. The help on WebDriverWait is over here. Remember, this is the help on the constructor. So when I'm up here and I look at the help on FluentWait, I'm not actually seeing the help on FluentWait, I'm seeing the help on the constructor. I have to come over here to see the help on FluentWait. And you can see that there is additional documentation there on the FluentWait, that it is worth you reading, getting your head right. It is always worth you reading the documentation. But we were going to drop into WebDriver. So let's drop into WebDriver. And you can see WebDriver extends FluentWait for a driver. So the generic part of FluentWait has been instantiated to a driver. That's why the until method works on a driver, a WebDriver, because that's what we're saying it does. And you can see here that the WebDriverWait class is basically a set of constructors. So we've got a constructor for the driver with a timeout, a constructor for the driver with a timeout and a sleep. So these all delegate off to this constructor down here, which uses the FluentWait directly. So it calls the FluentWait constructor, sets the timeout to what we passed in, sets the polling every, and ignoring a not found exception class. That's what makes it ignore the not found exception. FluentWait by default doesn't. So that's the WebDriverWait class. It's a very, very thin wrapper veneer on top of the FluentWait. The FluentWait is where all the action happens. And that's why when we do a with timeout at the top, we get a FluentWait returned. It's a FluentWait that in the case of the WebDriverWait will return a WebDriver, but it's still a FluentWait, not a WebDriverWait. That's why we have to cast it. I hope now that if you were to look through this code, and I encourage you to do that, you will get a feel for how it works. All the action, everything is really setting things up until the action happens in the until class, which is down here, the generic until. But you can see here, all the magic in this class happens in the until. If you read through that, you get a handle on how the polling works. But all I really wanted to show you was that we're building on top of FluentWait. And that's why we need to cast it here if we do any of these underlying methods and want to store it into a variable. If I use it directly, this is fine. It's changing the value on the wait itself, but it's returning a FluentWait. I can't put this into wait because it's returning a FluentWait. I don't need to put it into wait because it's already all the methods act on this, so it will store the values in the object. Quick run through of how WebDriverWait relates to FluentWait. And that's how we can use FluentWait to work on different objects. So I'm hoping that that has set you up for the next set of exercises. If you get stuck on it, again, don't worry too much, because FluentWait is not something that most people use. It is there, it's very important, we have access to it. If you get your head around it, great. It's going to give you an edge over some of the other guys you're automating with, but you'll get along fine probably with just the WebDriverWait. So welcome to your FluentWait challenge. Now I want you to use a page, compendiumdev.co.uk/selenium/javascript_countdown.html. I will show you that page in just a second, although you've seen it in some of the other lectures. Your job is to create a FluentWait that returns a string when the time has the last two characters of 04. And you should be asserting that the returned string says 01:01:04. And I want you to do the same with a WebDriverWait. Now how you choose to implement the FluentWait is up to you. I will show you the example that I come back with. But hopefully this will be a good comparison exercise to see what you can do with FluentWait and how it compares with WebDriverWait. So let me show you that page that you're going to use. So this is it. When I refresh the page here, you'll see it starts on 0101. It will count down. When it gets to 04 on the end, there, your job is to return that string and assert that it was 010104. So best of luck. When you come back, I will show you my answers. And now let's look through the code that I created for that exercise. Now you can see I've already run the test, all 3 of my tests fast. I didn't see the point in showing you it. You've already done the exercise. They will look exactly like going to the page, seeing the countdown, hitting 04, coming back. So what I have done, I have an app before class where we go to the page. Then for each test in the app before, I refresh the page to make sure that the countdown is just starting. I get the countdown field, I find it. Then I'm waiting until that countdown is visible just to make sure it's ready. Then, this is the FluentWait answer that I created. What I have done is create a FluentWait that waits on the web element, because remember I already have the countdown web element. I pass that in, I wait for 10 seconds, because if after 10 seconds it hasn't counted down by 6 seconds, we have a problem. I'll poll every 100 milliseconds. Then my until is a function, let's open this properly, is a function that acts on a web element and returns a string. My apply method acts on a web element, returns a string. There we go. So my synchronization is get the text for the element, check that it ends with 04. If it does, return the text of the element, otherwise return null. So we're fairly familiar with those constructs now. The WebDriverWait implementation that I have here, much the same thing, but I have to create a function which acts on a WebDriverWait and returns a string. I could have just written an expected condition, but I'm showing you how we use the same thing. Up here in FluentWait, we had to use a function. Here I'm using a function in my WebDriverWait, but instead of a web element, I have to pass in a WebDriver. So my apply acts on the WebDriver, which means that I have to find the web element before I can act on it, then do the same thing. Get the text, check that it ends with 04, then pass back the same results. So then I'm using an expected condition. So I've created a new expected condition that returns a string. Remember, it's an expected condition, so we know that it takes a WebDriver in its apply method. If it's a function, we have to tell it what it takes in the apply method. So it's an expected condition that returns a string. Because it's an expected condition, it takes a WebDriver. Then it's exactly the same code as I had above. I have to find the web element and pass it back. So you can see that the FluentWait allows me to work at a different level of granularity and different level of abstraction because I'm working with the web element itself rather than with the higher level WebDriver. So I have to do less in the synchronization point. So that might be useful to you. And in the example, you've already seen that the FluentWait itself doesn't even need to work on anything related to WebDriver. It can work on any object we want. Okay, the implicit versus explicit wait debate. Now throughout this entire series you have seen explicit waits. Explicit waits are the WebDriver wait. It's the expected conditions, it's the FluentWait, it's the function, it's the predicate, it's all those things that we've been using to actually wait for things explicitly, where we have been in control of the wait and we have said, at this point I am going to wait. Now, WebDriver does supply an implicit wait. And if we set it by saying driver.manage.timeouts.implicitly wait 10 seconds or whatever else we choose to put in there, find element or find elements will wait for that period of time. The default is 0. I think that's a good thing because I think that forces us to think about synchronization and make our synchronization very explicit, which makes it very maintainable, which makes it obvious when we're waiting for something when we're not, what risks we perceive in synchronization, and makes it a lot easier to fix intermittency, because the cause of the intermittency is usually an obvious missing synchronization point. By default, the implicit wait is 0. Find elements, if it cannot find an element, will poll for the time period that the implicit wait has been set. So if you set it to 10, when find elements is looking for something, it will look to see if it finds it. It can't, it will wait for a little while, then it will try again, and it will go through that sequence, that loop, for the implicit wait timeout section before throwing an element not found exception. If the default is 0, if you set it to 0, then as soon as it cannot find it the first time, it will immediately throw an element not found exception. So why might you want to do this? Because clearly, if we had done this in our go to the basic Ajax page, click on the combo, click on the next combo, if we'd used an implicit wait, we wouldn't have had to worry about synchronization at all, because we would have clicked on the first combo, looked for Java, tried to find it, it's not there. Then it will wait for a little while, then it will try again. It's not there. Then it will wait for a little while, then it will try again. Then it finds it without us having to write any code, just by increasing the synchronization time. You don't have to worry about it when it's implicit. You just have to worry about later when you encounter intermittency and you don't know where it is because you haven't thought about synchronization. If you do decide to use implicit wait, because it makes your life easier, because it allows you to not think about the risks, then I think you're probably not doing your job properly, because you should be thinking about the risks and you should be thinking about the synchronization and you should be taking that into account when you write your tests. However, if you choose to go down that way because you're trying to knock out these tests fast, the implicit wait makes it easy for you to just get the stuff out there, not think about it, and you worry about synchronization later, then it's important that you do start worrying about synchronization later and dialing down the default time for your implicit wait, so that you expose more and more synchronization problems that are related to the implicit waiting. Part of the reason for doing this is that if you use implicit wait, sometimes you don't get the feedback that your test has not worked for a long time, which makes your test slower to write. In the combo box, if I have a test that clicks on the server, then is expecting Java in the second combo box, with my implicit wait, it will take 10 seconds before I get the feedback that Java has not been returned from that Ajax call. Now if I have 20 or 30 tests in that area, that's 20 or 30 times 10 seconds that my tests are going to run for longer than they need to. So implicit waits can make your tests longer to run in the event of a failure. It also means that sometimes when we're waiting for things not to appear, if we choose to do that by use of trapping not found exceptions and trying to find the thing if it's not there, capture the not found exception, then carry on. If we're using implicit waits, those wait for the thing not to be there tests will take longer. They will take as long as your default synchronization time. So it's your choice. I have spent this whole session dealing with explicit waits because I think it's very important that you know that in depth, because that's what's going to make your test robust and that's what's going to push you, elevate your abilities as an automated tester rather than relying on implicit wait. I think you'll become weaker as an automated tester the more that you rely on the implicit wait. But if you're making a deliberate choice to use implicit wait for speed reasons and you understand the risk and you understand the tech debt that you're building up in your system, then it's your choice and you've made that choice and you're aware of what you have to do in the future, which is gradually reduce that implicit wait time to expose the synchronization problems so you can target them with explicit waits. Okay, let's look at implicit waits in code. So this is the test that you saw before. This is where we go to the page, we click on combo 1, then select Java, then submit the form, then we're on the page. And previously, remember, before we select Java, we have a synchronization issue because it's using Ajax. So our solution is to set the implicit wait to 10 seconds. Let's run this test and see what happens. Remember, we've not put any synchronization in there explicitly It's all done through an implicit wait. There's the Ajax, click the button, the test passed. Yes, we rock. Well, no, we don't. We're pretty bad. We've just hidden the fact that this is using Ajax. We've just hidden the fact that we need a synchronization point in here. We've just hidden the fact that sometimes we need a synchronization point over here. But we have the synchronization points on the find element with 10 seconds. So if we were just trying to knock these tests out, we didn't want to think about it, we're going to throw the tests away, then we might decide, you know, let's just set up an implicit wait. 10 seconds, let's go. What happens if it waits longer than 10 seconds? If the Ajax takes longer? The tests are going to fail, and we're going to go, why is it failing now? I don't understand. Because we didn't put any synchronization points in, so we've nothing to target except ramp up the implicit wait time, which then slows down other tests, and we have this knock-on effect that because we're using implicit waits, our test pack slowly degrades and no one wants to run it. And everyone goes, this tool is rubbish, when it's us not being explicit about our synchronization. So let's have a quick look here. What else have we got? So I put together a quick example because implicit waits make missing elements slower to find. So we have a test here that says check the time that it takes to find some missing elements with no implicit waits, then set the implicit wait to 10, then check how long it takes. So let me just run this test. So there's no implicit waits on that test. That went fairly quickly. Now we have an implicit wait of 10 seconds on this particular test. Uh-oh, the test is taking a little bit longer to do the same thing because we've got implicit waits. And this is the danger. This is what happens. This actually happens in production code when you use implicit waits. Your tests get longer. You get feedback about errors later. It's slower to run the test because an error happened, but you're still implicitly waiting for that field, so you don't find out that the field is missing for 10 seconds longer than you should. I'm going to encourage you not to use implicit waits, to be very explicit about your waiting, to make it obvious, because then you have much more control, you have a finer grained control, you'll get faster feedback on your tests. And they're much more maintainable, and it's obvious where to fix intermittency problems. If you use implicit waits, the default that people use for fixing their intermittency problems is to increase the default wait, and that has a knock-on effect on all your other tests. So it's your choice. I'm going to encourage you not to do it, but at least now you've seen it and you know that it is there. Okay, we've covered quite a lot. I just want to draw your attention back to some important points in terms of the usage of the WebDriver wait within your tests. So remember, to make the waits more readable, wrap your anonymous classes in a method. In the same way that the ExpectedConditions class does, every single one of those ExpectedConditions is an anonymous class wrapped in a method. That method is statically exposed from that class. Make sure that in your anonymous class, or if you create ExpectedCondition classes, that you override toString to help people later on. In your test itself, create a wait variable. So instead of doing new WebDriverWait all the time, assign that new WebDriverWait to a wait variable so that later on your test you just say wait.until. Just makes things a bit more readable. If they're all using the same wait, they're all using the same driver, then that will help. Make sure that when you do use ExpectedConditions that you import the method statically so that in your test you say things like until element is visible, that kind of thing. And remember, what we're trying to do with these waits is wait for a thing and then use it. We don't really want to create custom waits which return a boolean, then knowing that the thing exists, go and find it, then use it. We want to return the web element itself. We want to return the string that we're going to act on. We want to wait for a thing and then use it. So let me show you that in code. So I have here some running tests that I have refactored to try and illustrate the points about making your weights readable. So at the top here, I have a WebDriverWait, and I'm instantiating that in the @before method. I could have done that in an @before class method. Regardless, I am instantiating at a higher level than the test, so that this can be reused across the tests, which means that in the test, I will just write wait.until. Makes things a little bit more readable. Here, I have waiting for a thing, then I am using it. I don't even need to put this in this variable if I don't want to. I could just say wait until option with display dot click. That would work just as fine. Wait for a thing, then use it. If it's disposable, why not do that? It's up to you. But the general principle is wait for the thing, then use it. So for the anonymous classes, for our custom expected conditions, wrap them in a method. So here I have one called option with value displayed wrapped in a method, and I'm overriding toString to help us with debugging and various other things later on. When I use it, it's returning a web element so that I can wait for the thing and then use it. When we use expected conditions, let's make sure that we import them statically. So instead of doing expected conditions dot element to be clickable, let's just do element to be clickable and import that method statically. Then our test becomes a little bit more readable because we're saying wait until element to be clickable, then the element. So that's fairly quick, but it does make a difference in your tests. It's up to you. I mean, I still write new WebDriverWait at different points. Sometimes I will push them up. If you start with getting in the habit of pushing things up to the highest level, then reusing them, you can start to introduce a much more literate style into your code, which will make them easier to read and will help with maintenance. So page objects are massively important. This is our introduction into abstraction layers in general, because when we're working with pages or web applications, what we used to do is abstract away the tool that we used to drive the browsers. So like Selenium, we would abstract that away in order to abstract the browser automation. WebDriver does that for us. WebDriver is a browser automation abstraction. That's why we say driver.getTitle, things like that. Those are the things that we used to write a wrapper around for Selenium. We don't need to do that anymore because we've got WebDriver. We still need a higher level of abstraction so that we can model our pages. Otherwise, we end up doing what you've seen in the test, which is pretty much like this. Let's have a quick look. So we say things like driver.findElement, then click on it, then driver.findElement, then click on it, then wait until a certain thing happens, yada yada yada. This makes our tests very specific in terms of using WebDriver, and they're not specific in terms of our domain or our application. And that's where page objects come in. Page objects are going to be an abstraction layer on our physical pages or on the page components. Essentially the web application, we're going to model it in terms of a set of objects. Using page objects will allow us to remove the actual WebDriver code from within our tests so that we actually model and work with the physical domain. Now there's a whole bunch of ways of doing this. We're going to look at, in fact the three that we're going to look at are the page factory, which is given within WebDriver itself as a set of objects, which can be a fast way of building up these page objects. We're going to look at the loadable component, which is an interface that WebDriver now provides for helping you build standard type page objects. And we're just going to look at creating basic objects, standard Java objects that wrap around the application that we're working. Now all of this, when we do this, all we're going to do is give you the facts about these are page objects are classes, page objects allow you to not have the driver code within your tests, but we're not really going to be exploring the modeling decisions that are required when you build page objects. Because when you look around the web, you're going to find so many different ways of creating page objects. There's going to be people recommending that you add wait for loaded messages, methods. There's going to be people recommending that you expose the elements directly so that you don't have to write getters around those particular methods, because there's no point, because you're going to use them. You're going to see abstraction layers like Jeb, which offer in Groovy different ways of constructing page objects. This is a very wide area to cover. So we're going to cover the basics and show you different ways of doing it. But you have to be aware that the responsibility for how you model it is a modeling decision. And the more that you learn Java, the more that you learn object-oriented programming, the more that you learn domain-driven design and coding to interfaces, the more that you will change the way that you do this. Because this fundamentally is the area that we learn most about as we're writing our tests. And we continue to learn more about it. And people do this in a whole bunch of different ways. People create objects that wrap around web elements to get specific types of web elements. So you've seen the select helper class. That's a form of page component which wraps at a low web element level. There's different levels that you can do this. And you can take this further and extend it into domain objects so that you no longer have to write your test just in terms of the physical page, but in terms of the logical actions that your users are going to do. And that's where BDD style of test comes through. So there's a lot to cover in this area, and we are going through the basics. So do not think that after going through this, you know exactly how to write page objects. You don't. You know how to start working with page objects so that you can learn more about it. So the approach that I'm going to recommend to you for creating page objects is refactoring to page objects. So you write tests, you have the driver.findElement, weights, etc. all in your tests, and then you try and refactor that out. So that you move from writing something like this, where you do findElement, click, etc., and instead move to something like create a new page, get that page, select something on that page, select something else, then click. And it becomes much more readable at the page object level. So some ways of doing that are, we want to, in our local tests where we create abstraction methods, and you've seen me create helper methods in my tests, we want to move those out and push them into a page. We want to move them into a higher layer of abstraction so that they can be reused. Because very often you'll find that you create a method local to one test, you want to reuse it in another test. If you're not using page objects, typically you'll move that into some helper class somewhere. Really what we want to do is model our applications as effectively as possible, and we have to decide whether that should go on a page or whether it should go in some sort of process helper class. So one thing we want to do is minimize the amount of comments in our tests, because we want to be able to read our tests and have the test clearly explain what it's doing. And we can do that with abstractions. When we make our abstraction layer as clear as possible, we can remove the comments. So one guide to constructing your abstraction layer are the comments that you put in place. And we always have to make decisions about the model that we're building based on the readability of it in a test and the way that we're going to reuse it across tests. Sometimes you will create two methods, two classes, which are very similar in order to support readability rather than just reuse. And what I'm going to suggest to you is that you build it only as you need it. That gives you the opportunity to refactor consistently as we go through. And you've already seen that the IDEs are really good at helping us refactor. There's a whole bunch of refactorings in there. We will use those a lot when we start doing page objects. So remember, page objects, we want to try and move from this kind of coding where we're using driver directly and we've got comments in there to explain what's happening, to something where we have no comments. It's blatantly obvious what we're doing within this. So I'm going to give you an example of refactoring to page objects. We're going to start with one of the tests that we already have. So I'm going to use the synchronization with WebDriverWait test that we wrote ages ago. Now, this has a number of tests which all do the same thing. The main difference between all these is the difference in the wait classes. So when I do finally refactor this to remove these local methods, because remember what we're doing is working with this basic Ajax page. So we have this basic Ajax page which has a page, it has some components. We can see here there's a category drop down, we've got a language drop down, we've got a code init button. This is a candidate for page objects, and you can get a feel for what we're going to do. We're going to select category, select language, click code init. Now remember that when we do this, we have the Ajax element come up. So there is some candidate for removing that wait for the Ajax entirely, or making it easier for the tests to check that the wait is there. But essentially we no longer want to do the driver.findElement, this drop down, click on it, select the next thing, da 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 da. We want to move all this into a page object. And the reason I've chosen this test is that we already started to make our test more readable by creating local methods. So in my test I've got a start browser and select server local method. I've got a wait with a clickable. Then I've got another set of local methods which select Java and submit form and check results. Now this makes the test readable, but anything with an and in it for a method name is pretty specific and makes it a lot harder. Because if I want to do start browser and select desktop, do I create another method called start browser and select desktop? Do I split this into start browser, select desktop, select server? This is where the modeling decisions start coming through. So we are going to model this in terms of page objects now. So I've basically just copied that into a class in the page objects called without page objects test. And I'm going to create a new package. And we'll call that refactor example 1. I'm going to create a class in here. Call it basic tests refactored. And then I'm going to do what we never do, which is copy and paste the contents. And the reason I'm doing this is because I'm trying to keep the code base clean for you, that when you read the code base, you can see all the different examples and steps and processes. You would just work with the without page objects test or whatever other class you're trying to refactor. So we've got a test in here now. It has local abstraction instead of page objects, and we want to refactor them. So the place that I'm going to start down here at the bottom, because this is where I already have been doing refactoring. So let's start here. So what we do here is we do a driver.get basic Ajax, select a category and click on it. So let's start with this line here. I want to work with page objects. So I'm going to say driver equals driver.get, and then I'm going to say that I want a basic Ajax page. I'm going to call it basic Ajax page object, because I've already written some code around this that looks very similar. So basic Ajax page object, I'll call it basic Ajax page equals new basic Ajax page object, and I'm going to pass in the driver. So I'm going to inject the driver that we've created into this page object so that it knows what
browser and driver to use. So let's create this class. Refactor example 1 dot, let's call it pages. Great. So now I've got a page object without a constructor, so this doesn't work. So let's create that constructor. So now we've passed the WebDriver into the page object. I want to store that for later use, so I'm just going to quickly call that a driver. Then in here I'll call it, then we make that a field. Great. So now I have a page object. It has no methods in it, but it knows about the driver. So any other method that I use in here can use this driver to do stuff. Let me get rid of that. So that's this line almost removed. But first of all, I do a basic Ajax page, and now that I've got a basic Ajax page, I need to go to it. So I'm going to say open. I'm going to call that open just to start with. In fact, I'm going to call that get. Then it keeps it slightly in sync with the WebDriver API, because we do driver.get a page, so I'm going to say basic Ajax page.get. But you make these decisions as you're modeling. My initial thought was open because I'm opening a page. Now I'm doing get to keep it in sync with the WebDriver. You get to choose what's appropriate for your domain. So I'm just going to copy this for the moment, because that's going to form the basis for this method. Now I don't need this driver anymore. I'm just going to use the basic driver. So let's make this simple. So you can see the path in here. Now this is going to be the only time that this path is ever used now. So any other time I want to access this page, I'm going to create the page object and get it. Now further refactorings I might choose to do are refactor this out into common constant somewhere for application. So because that might change, we might move on to different environments. We might want to control that through Hudson and Jenkins. All of these are modeling decisions. At the moment, I don't need to make that decision because we're working with a single environment and it's on this server. So jumping back in here, now I can get rid of this completely. So now I have in my start browser and select method, we get the driver, we create a page, and we get that page. So then I want on that page to select server. So what I'm going to do is I'm going to say basic Ajax page dot select category, because that's what we're doing here, category select. And to start with, I'm going to say I want to select category number 3. Let's say that, select category 3, because that's what their test currently models. Let me create that method. Select category int, and that's the category value. And this is the code to select that category. So I'm going to copy all of this out, or cut all of this out, because it doesn't belong as a local method anymore. It belongs in the page object. I can remove this comment, and then in here so you can see what we've done now. Now I have made this flexible. I can, in my tests, instead of saying select server, I can select any category in that drop down based on the value number. Any category is going to go in to find that combo 1 and select that category. So what I'm going to do, because this is used across all the different tests, I'm actually going to move this out and stick it in a setup method. So I'm going to say at 4 so driver.get, construct a page object, then use it. Now this page object is going to be used by the test, so we need to move this out into a field. There we go. Oops, setup est, setup test. So now I have a setup method that will run before all these tests, which will get the driver, which will create the page object, and then go to that page. So now this start browser and select server method looks like this select category. So what we can do is we don't need this anymore. We can now make this readable. So I'm going to use refactoring. And I'm going to refactor this inline. And what that will do is replace the contents of this method anywhere I previously used start browser and select server. So you can see here, this test says start browser and select server, start browser and select server. We moved the start browser up into the app before method. Select server is what this is doing now. So I'm going to refactor this inline. So you can see now I no longer have this local method, and my tests say basic Ajax page, select category 3, select category 3, select category 3. Great. So that's the first part of our refactoring. So now let's start working through this test by test. So this test says wait until the Ajax symbol has gone. Great. So let's code this, let's refactor this. So at the moment, I'm just going to work through this directly and say WebDriverWait until basic Ajax page, because at the moment I'm saying everything is in terms of the page object. Basic Ajax page dot Ajax action is complete. So that's the level that I'm going to work at here. Now this method does not exist yet, so let's create it. I'll leave that like that just now, because when I put this in place, it will complain that the return type is not correct. So let's make it return what it did before. So now you can see my page object can return an expected condition for this Ajax action being complete. So my test now can wait until the page is finished. Now this is a decision that I have allowed the test to have a finer grained waiting control. So this is waiting until the action is complete. I might choose to move this wait into the select category so that all I have to do in my test is basic Ajax page dot select category, and it will do the wait until the Ajax has gone away. Now it's going to depend on the type of test that we write. I may want to have tests that actually check that this Ajax symbol is displayed. And if I put it all in select category, I may not be able to do that. So at the moment, I'm just going to leave this here. Now the next test, because all these tests were very similar, they were testing very much the same thing. Instead of waiting for the Ajax to complete when it selects category, it waits until the thing that we want to click on is complete. So essentially, we're saying, I don't care what we do, I just want to select the category. So that means I'm going to make a decision now to move the wait into the select category, so that when I do a select, I do a wait then. Now, just for historical reasons, I'm going to move this into this method. I don't need to do this. This may be confusing, but I'm just going to add this as comments in here. saying we could also wait for the contents of the drop down to fill. Instead, wait for the Ajax symbol. So I'll move that after the select. So I'm putting the synchronization point in the select category method, whereas previously we had the synchronization point in the test. I may revisit this decision later. That's okay, right? The whole point is we're making decisions as we go along based on what we think we need to do. So because this method is in here, now I've still got the ability in my tests, because I made this ExpectedCondition public, to wait until an Ajax action is complete. But I'm wrapping it up in select category. Now if I ever want to just do this and not wait, then I may choose to refactor this out into another method that says click on category, which would be different from the select, because the select is going to be a domain. I'm doing an action, I'm doing a select, and I'm going to wait for the action to happen. I might choose to just click, and I might choose to not wait. I might choose to do something else because I'm trying to trigger some error conditions. Instead, we're wrapping this wait up in the select category just now. Now that has an impact on the rest of our tests, because select category now does a wait. I don't need any of these other waits in my tests, because all of these were synchronization points that said when the category is selected, something populates in the dropdown. So now I have this select Java submit form and check result. That's what we're going to refactor now. So this seems pretty simple. What we want to do is basic Ajax page dot select language. Not a language, language. And I will pass in, as before, 23, because that's what I'm doing here. So at the moment I'm not thinking very much about the context of the test. I'm just thinking, how do I get the page objects to support my tests as they're currently written? Once I have done this, I will then look back through the tests and refactor further to see if the test itself explains to me what it's doing. So let's create a message called select language. And that's going to be language value. And I do that like this. So my select language is going to find the correct combo, then find the correct option with the language value that we want to select. Then I want to do basic Ajax page dot click code init, which is basically saying click on that button. So create that method, come back, get the code that implements that, and stick it in here. So now I got my basic Ajax page, select this, click on it, then I have a wait, and this wait is waiting for the title to change, and the title changes because we've gone to a new page. So there are a number of ways I could do this, and what I'm going to choose to do is I'm going to create a processed form page, and I'll call that Yes, I will call that processed form page equals new. So we're creating another page object. In the page object, we're going to inject the driver that we're using so that it knows what to do. Then I'll create this class in my page object folder. Next to driver. Let's finish this off while we're here. Just going to rename that to a driver. That's just my style of coding that I'm comfortable with. You can choose to do something else if you want to. Great. Now back to this. So I have a new page object. So again, I have a number of options. I could keep this the same, new WebDriverWait, until ExpectedCondition title is processed form details. That would work fine. I could wait until and then do a check on the title of process form. Or I'm going to do this. I'm going to say wait until page is loaded. Now this may become a common pattern in your tests. You may constantly be doing this. So you may create an interface that you want to code to called wait until page is loaded or page synchronization or whatever you choose to do it. But at the moment I'm just going to make this a method on the page. And as I see more and more code repeating, I will refactor up to interfaces. I will refactor up to common objects. At the moment, I only have 2 pages, and only one of them currently I am waiting for it to be loaded. That might change as the tests go on. As tests start failing, I may need additional synchronization points. But for the moment, I'm going to take this out of here and push it into the page object. And because that's using the driver is there, this is the title. So now this page knows about its title and other tests and other pages don't. So I only have a single place to change this title and it's in the page object itself. Wait until page is loaded. Great. So now I want to be able to check that this value is on the page. Now this is a very generic page, this processed form page. It basically, you send it something in a post, it shows you all the values and fields that you've sent through. So I'm going to make this a bit more generic, and I am going to say, I'm going to have a processed form page get value for, because that's what we're doing. We're getting the value for a particular ID. So this is the language ID. It's just that when this is displayed on the page, it puts underscore value on because it's a dynamically generated form. So I'll have to return a string for that. Let's leave it like that just now until we refactor in. So what I want to do, so this is essentially finding it, then asserting that the value is correct. So what I want to do then is keep this pretty much the same. So I will say assert equals expected Java code 23 get value for language ID and push the code in here. So let's say field value element, find that, then I will return field value element dot get text. That's what we did previously. So now I can pass in, as soon as I change this, I'll call it value ID. So now this is generic. I can, in this page, check for the value for any ID that I'm looking for. And in this instance, it's the language ID. So now I have refactored this into page objects. So what I'm going to do is refactor this inline. So now, this is quite simple. All these tests are pretty much the same now, because that's all they ever did. They all checked for the same thing, they just checked it in different ways. So we select a category, we select a language, we click code in it, and then check that the language that is displayed is the one we were expecting. So what I think it would be useful to do is to make these tests more explicit, or more obvious what's being tested here. So I don't want to just select category 3. I want to say select category. Oops, let's not overwrite that 3 yet. I want to say select category basic Ajax page object dot category, and I will change the static includes later on for this, but I'm just building it up this way. Basic Ajax page object dot category dot, and I think 3 was server. So that's what I want to say. Instead of the 3, I'm going to create an enum category. I'm going to move that up to the top of this page object. And we'll fill in the details of that in just a second. So I need to create a server in there. So let's create a server. Let's move this into the right place. Now obviously this is complaining because it's currently an int and we want it to be an enum. So let me just change this to category. I will no longer call that category value, I'll call that category. But that doesn't have the correct value anymore. So I'm going to make this a fully controlled enum, so that I've got server, and that's going to map onto 3. I don't have to do this, it could be in order, but I'm going to have explicit control over this so that if the developers or the requirements for the value for that server change, I can easily change it in this enum as part of the constructor and the value, rather than rely on the position in the enum. So currently we only have server in there. So I will create the constructor for this. Let's call it value. I will say this dot drop down value equals value. Let's create that field in this enum. Good. And then I want some way of getting that value back. So I'll say alright. So now I have created this enum for server. we're going to use that in here where we want the category. So I don't just want category, I want category value. So now I think it's time to bring in this differently. Oops. So let's statically import the category. There. So now I'm saying select category, server, then select language 23, then click code in it. So presumably we want to make these tests unique now. So I'm going to say choose to code in Java on the server. What other options have we got here? So I can choose on the web to code in JavaScript. So I'm going to say choose to code in JavaScript on the web. That will remind me. Then in here we also have web and we've got desktop, and let's change C++. Choose to code in C++ on desktop. Let me mark that in as a to-do. Choose to code in C++ on the desktop. So this will require me adding in an enum for the language. So I can say language.java and adding in category.web. And that's 1. So part of the advantage of putting these parameters in is they can be out of order if I really wanted to. So I don't have to put it in alphabetic order or whatever order I want. So because we're refactoring in this order, I'm just going to leave it there. I might choose that that's ugly later on. I still have to change to JavaScript. And then we want category dot desktop, and that is 2. Let's just double check that that's the case. Inspect element, web 1 desktop 2 server 3, web 1 desktop 2 server 3. Let's reorder this now that we've finished that enum. Now hopefully you saw there some of the benefits of moving into page objects, because now it's very easy for me to make my test flexible. I can now select any category I want from that drop down. Once I've changed the language, then I can put the languages in an enum. So we've got one for desktop, one for web, one for server. So I'm just going to delete this last test. I don't really need it. I've covered. Let's just make sure we just have coverage on the categories and one value from the languages. So let's finish these tests off. Select language 23 for server. So that's Java. So that one is the same as we had. So JavaScript for the web, let's find out what value that is. Web, JavaScript. So that is 0. So because I'm going to do this quickly, let's see if this works. So we're expecting a 0 to come back. Then CPP on the desktop, let's change to desktop. C++ on the desktop is 10. So this is a new test. We're now choosing desktop instead of previously the hard-coded, and we're going to select language 10 and check that 10 comes back. So what I'm going to do is I'm going to debug this particular test, because we've been doing this for quite a long time now. You've been very patient watching this video. Let's debug this. And see if it works, because we've done a lot of changes there. We've created a whole bunch of new objects, and we've now got a new test. And we've got a flexible way of using these. But we still don't know whether these work. So we still have some unfinished tasks to do. We should really create an enum for the language. And then we should use that throughout these expected results. But I'm going to leave that as an exercise for you once we get this working. So you will come in and you will fix this code in refactor example 1. Just take the code from the code base and start working through it. So we've got debug statement in there now. Let's move this over. So we're expecting it to choose desktop. Let's see if that happens. Hooray! Then it did the wait, then it came back. So now we're expecting it to select language 10. So I'm just going to manually fiddle with this and make sure that's what happens. Hooray! Selected language 10, which was C++, which is what we expected. Then it will click code in it. Then it's waited until the page is loaded. Then we're expecting, oh, we're not expecting Java code, so I'll have to change that. But we were expecting 10. So our test passed. So here we're expecting JavaScript. Now I haven't run this test, but you can run that when we do it. Now the reason I'm not running this is because there's when you come to the exercise, I'm just warning you in advance, there's a little bit more complexity around this. So you will have to go into debug mode and fix this test, because this test will fail when we start. But let me show you this. So it chose web and JavaScript, which are both selected, but we didn't get the right value back. So as an exercise to you, you're going to fix that particular test, and there'll be a couple of other exercises as well. So I'm going to stop this refactoring here, because what we've demonstrated a bunch of steps to go through, and we've partly refactored this test into a much more readable format. The next lecture is going to summarize this in case you skipped through this long, very long refactoring exercise. So I'm going to summarize everything, then we're going to get you doing the exercises and carry this work forward. That live refactoring was a bit of a long session, so I'm going to create a little summary here to describe what we did. So I'm going to jump back and forward between this slide and the code. But essentially, we based our tests on the synchronization with WebDriverWait test. That had a whole bunch of tests that were exactly the same, but we changed that to become 3 tests that actually add value. We've created 2 page objects as we went through that, the basic Ajax page and the form processor page. I've taken the local methods that were on the tests and moved those into page objects. Now I moved the synchronization code for the synchronization on Ajax image into the page initially as an expected condition and as part of the select category method. We may choose to refactor the select category further to have a click on category, which is used in select category to give us a method which does synchronization and methods which don't, because we may need that flexibility in our tests. we created an enum for category, and the enum was one that we controlled through a constructor in the enum to allow us the flexibility that if the page changes, if the values of the categories change in the page, we can easily change it in the enum. We've moved the synchronization on the title into a page object, and you saw that the tests are now easy to expand because I no longer have select and do something else as local method names. We now do things on the page, and the tests are now very easy to read. And we have a failing test. You saw that, so that's going to be one of the exercises. And we didn't finish turning the language into an enum, so that's something that you're going to do too. So let's have a quick look through the code to remind ourselves. So we took the synchronization with WebDriverWait test. I initially put it into a without page objects test, and then started refactoring into this basic tests refactored method. This test had local methods. These were moved into page objects. So this stuff here, creating the basic Ajax, that moved into the basic Ajax. That moved into the basic Ajax page object. And you can see that now we have a get method that goes to the URL. We instantiate the driver as part of the constructor. So in our test, that code becomes get a driver, instantiate the page object with that driver, and get the page. We moved this directly into the page object as a method, as the select category method. And so there it is there, there's the code. So we parameterized it by passing in the category. We made the category a enum, which is configurable in here. So if the page changes the value of the category, we can easily change that in the enum. So again, we only have a single place to change the enum. The category is passed into the select category method. If I want to do error conditions and try and click on things that are not there, then I might want to refactor this to allow that to happen. And you can see that I put the wait for the Ajax in this select category. And the reason I did that is the select category is what triggers that Ajax call. Therefore, the select category is what is going to wait until that Ajax is complete before allowing us to do anything else on the page. It will make it very easy to write simple tests that select a category, then select a language, then click on it, without having to expose the fact that we're doing an Ajax, that we have a wait in there. All of that is hidden behind this abstraction layer for the page object, making our test very, very readable. Now you can see that we still have to create an enum for the language. That's going to be an exercise you do. And you can see that I did a static include on the category to make it easy to use, because that category is contained within the basic Ajax object itself. I have to statically include it like this, but then that lets me write select category, category server. So we want to do the same thing for the language. And you can see that all the code we had to refactor was in these local methods already, because we'd done some local refactoring. And the only thing that was different was the wait, but we moved that wait into the page object. So then we had a refactoring to allow us to select a language. That moved into a method. Then a refactoring to submit the form. That moved into a method. Then this became a new page object. And the page object was the processed form page, where we wait until loaded. So this wait on the title became a method. This wait on the title became a method on the processed form page. So I now create a new form page, giving the driver in the constructor, then wait until it's loaded. Then I do a get value for the language ID on that form page and assert on it. So our tests become much, much more readable. We can see exactly what is being tested for. Well, we will do when you change these 23 into Java and the 0 into the JavaScript. But of course, you have to investigate this test and figure out why it's failing before you do that. So that's a quick summary of what we did in that big session in order to move from a set of tests, which we're using driver directly and local methods, into a set of tests which use page objects and are very readable with enums to help us. And your exercise now is to fix that bug, or investigate and fix the failing JavaScript test. So one of the tests that we wrote selects web, then selects JavaScript, submits the form, but that test fails. You need to run that test and investigate why it fails, then provide a fix for it. Then continue with the refactoring. And the refactoring I want you to do is to convert the language into an enum. So instead of passing in 23 or 10 or 0 or whatever else we're passing in, make that an enum in the same way that we did the category. And that's pretty much it. And if you want, then you can explore more tests and add in different combinations of category and language, because the tests now are very easy to make that happen. So you will need to work from the checked out source code, or the source code that's in the zip file, so that you can use the refactor example1 package, then just refactor that and take that forward. So best luck, then come back, I will show you my answers. This isn't really that hard, it's pretty much going through what we did before, but I want you to experience that notion of refactoring as well. And now to debrief on the refactoring exercise. So the JavaScript one was a bit of a red herring in the sense that it does expose an application bug. That is an application bug. The first time you load the page, the JavaScript has a different value than comes back from Ajax. So you could have chosen to fix that in a number of ways. I fixed it by selecting server from the category and then selecting web, because I made the assumption that the Ajax values were correct, and it was the initial HTML form that is incorrect. So that is a fix that I put in place. Now you may have decided that the Ajax was incorrect, and in which case your fix was to change the value that you used for JavaScript so that it's 1 and matches the initial loading. Now either of those requires an application change in order to fix the bug. We could go further and we could make the page object handle, has it been loaded by Ajax or is it still the default, and respond correctly based on it, in which case we're coding a workaround for the bug in the page object. I decided not to do that. And the other complexity was that when you put the enum in the language, there are two C++s. There's one C++ for server and one C++ for desktop. And I handled that just by putting in two C++ in the enum. So let me have a look at the code. So here we go. So I have the refactor example1 exercise based on the refactor example1 code. So here's my test. So we had to add a language enum, which I did. It's fairly simple. I used much the same format as the category enum. I suspect you might have done too. And the only complexity was I needed to add a server C++ as well as a desktop C++. And hopefully you managed to get these values correct just by looking at the DOM, by inspecting the DOM when you actually run through and do the manual work on the page, because that's how we build up our page objects. We have to do the work manually, see how the page changes, investigate the DOM, look for the XPath, look for the CSS selectors that we're going to use, etc., etc. We have to build up these page objects by investigating the application. Then there's the JavaScript on the web. All I did was select server, then select web, because this forces the change to happen to cause an Ajax event to trigger, therefore the correct language is in there. And this is actually a bug that I coded into the application deliberately to help make the automation a little bit harder or more complex. But there's obviously a couple of ways we could handle that. We could choose to decide that the Ajax is buggy, in which case we'll code it against the initial versions in the HTML. But either way, we'd have to raise a defect against this to get an application change. Then coding it in C++. Again, why did I put in different values for the C++? Because it forces us to model it differently. Now we could have done it so that C++ has two values. We could have coded it to add additional complexity. I decided to make it very simple, have a desktop C++ and a server C++, because that's what the application models as. So again, there's nothing different in there. Feel free to look through the code, but I didn't have to change anything in processed form page, and the only thing I added in here was the language, and then of course in the select language to use the enum instead of an integer. So it's a very simple walkthrough of those exercises. Hopefully you did something similar. If not, flag up any questions or concerns in the forum. Now let's have a look at the loadable component. Loadable component in order to represent page objects or components that can be loadable. I haven't actually used it in production, so we're going to have a look at it now, and we're going to look at it in the context of the page objects that we had. Essentially what you do in order to turn your page object into a loadable component is that you extend the loadable component. Loadable component uses generic, where you have to define the object that's going to be returned from the get method. So here I would do extends loadable component basic Ajax page object. I have to implement a load method, and the load method does the work to load the page or the component. And we have an IsLoaded method, which, if it is not loaded, throws an error. And we receive the get method for free. So normally we just do new page object, if it implements loadable component, then call a get on it, and that will do the actual work. If we call the get multiple times, then it doesn't load the object multiple times if it's already loaded. That's the kind of main benefit of the loadable component. So let's have a quick look in the code. Okay, so here you can see that I've made the page Ajax, the basic Ajax page object, a loadable component. So this now extends loadable component basic Ajax page object. So what that means is when I look at loadable component here, we can see that the loadable component is an abstract class. When I do a get, it will return this. So it will return the page object that I'm looking for. If we look at the get here, we can see that when I call get, it says try and is it loaded? Remember, IsLoaded returns an exception if it's not, or an error if it's not. So I try and do an IsLoaded. If it's not loaded, we catch the error, then we load it. Then we come down, check, is it loaded? If it's not loaded at this point, remember it will throw an error which will bubble up. And if it is loaded, then it will be returned. If I call get when it is loaded, so I come in, I go get, try, is it loaded? Yes, okay, return it. So we don't actually call the load multiple times, which might speed up your test. Then you can see we have to implement load, and we have to implement it is loaded, and is loaded throws an error. So in the context of the basic Ajax page object, our test remains unchanged because when we created the object, we said it uses the get method in order to bring it back. So that was a piece of fortunate luck, assuming that we didn't know the API in advance. But we were modeling the WebDriver API, and it has a get, so we put a get on our page object, and that's really what the loadable component is also doing. So in the page object itself, in order to implement the loadable component, I've had to remove the get method. Right? Our get method, if I put it back, so we had a get method like this. It was public. That's all it did. And you can see that this is saying, wait a minute, this is not right because it should be returning the page object. Okay, let's make get return a page object. So at this point, I've overridden the get that was from the loadable component, so there's no point doing that. So we get that pretty much for free because it will call our load method, and our load method now does what it takes to load that component. and we have an IsLoaded here. So in order to determine whether the page is loaded or not, I'm just going to check for the correct combo. So that's the correct combo. So I'm doing a try, is this combo present? Catch a no such element exception. If it's not, then throw an error, basic Ajax page not loaded. Then in my test, when I do a get, it calls the get from the loadable component. So there's no real difference in here, except that if I subsequently call multiple gets, it won't actually do the work. So in here, so let's see if we can illustrate what happens. So if I do a get, if I call it multiple times, it won't actually make any difference. So that's the main benefit of the loadable component. Now the question remains, should all our page objects use loadable component? Loadable component is fairly new. I suspect at some point someone will come up with ExpectedCondition.isLoaded that will use the loadable component interface to check whether it's loaded or not and wait until it's actually loaded. Now the question is, the processed form page, should this be a loadable component? Now the reason I'm asking that as a question is that the loadable component has a method get. Now we will never call a get to create a process form page, because process form page happens as a result of some other work. Now the notion of IsLoaded is useful for processed form page. So it is a loadable component, but it's not a loadable component that we trigger with a get. So if I was to add loadable component in here, I would basically be saying process form page extends loadable component for a processed form page. Then it's saying you need to implement those methods. So let's implement them. Load and IsLoaded. Now I will never do anything here, because we will never manually load this process form page. IsLoaded is a valid thing. So for IsLoaded, I would have not driver.get title content equals this. So I'm basically saying it's loaded when the title has changed to this. And if it's not that, it's not loaded. So we want to throw a new error. Page was not loaded. And that would meet the conditions of the interface. But I can now do a process form page.get, which will do nothing except check that it's loaded. So over here in the test, where we do a wait until, I could do a process form and that will check if it's loaded or not. Because it's protected, I don't have access to the IsLoaded, but I can call the IsLoaded through the get method. And if I've waited until it's loaded and somehow that has passed, then this get will fail if it's not correctly loaded, but this get will do the IsLoaded check. So I'm in two minds as to whether processed form page should implement this or not. These are the kind of decisions we have to make when we're modeling and when we choose to use the classes that come with WebDriver. In theory, this is a really good idea when it's something that you can call with a get method. So a normal page, this is great. For a component, does get actually make sense on it? It may be that what you want is a wait until. So it may be that what we need is a loadable by something else. I don't know. But essentially this is just an overview of the loadable component. This is in WebDriver. So we'll start to see more people making use of it. Over time, there may be other features of WebDriver that take advantage of this interface that's exposed here. So the IsLoaded may well be used by other methods. At the moment, it's essentially a convenience method for creating a get method which doesn't reload the page or the thing or the component if it is already loaded. That's really the advantage of the loadable component. So one of the things we have hidden away in the WebDriver is a slow loadable component. Now you use a slow loadable component when the thing that you are waiting for may take some time to load. Because the get on the slow loadable component will poll until the IsLoaded actually comes back with a true, or it times out. So there's a kind of built-in WebDriverWait for the loadable components. So in the previous discussion, when we were saying, is the form processor page a loadable component? Well, maybe it's a slow loadable component, because when I turn it into a slow loadable component, I don't need this wait until page is loaded anymore, because we get that for free with the get. So the way that I do this, so I've made the processed form page extend slow loadable component. I don't need this wait until page is loaded anymore, and we'll see why in just a second. I never do anything in the load, that's okay. But my IsLoaded is valid. My IsLoaded says it is loaded when this title has been met. And we get a get for free because we're extending slow loadable component. So in the test, instead of saying processed form.wait until loaded, I just say processed form.get. And the get is from the slow loadable component, and you can see that what it does here is the same thing it did before, which is if it's loaded, then return it, catch an error just in case, try and load it, then the slow loadable magic kicks in, which is basically, now we're going to wait a certain amount of time. If during that time we haven't found it, then keep trying, catch the errors, then one last time, check see if it's loaded, if not, throw the error. If it is, then return the actual page object. So we have a built-in wait in the get method. And you can see here that it sleeps for 200 milliseconds. Now the way that I use this in the process form is because I'm extending slow loadable component, I have to call the constructor for the slow loadable component in the constructor for my page object, and I tell it to use the system clock. I tell it to wait for 10 seconds. And that allows me to get rid of this wait until page is loaded method entirely. Even though I don't do a load, it is valid for me to try and get it and check that it is loaded. So that's kind of what the slow loadable component is for. So page object factories. In our existing page objects, you've seen me abstract code away and do find elements to get web elements that we can then use. And these are all wrapped in a method on the page object. That is very simple, makes a lot of sense, nice and easy. Now in the Java version of WebDriver, we have some helper classes that we can use called the page factory. The way that the page factory works is instead of doing find elements within the code here, if I scroll through, you see that previously down here I did a web element language select, then find element to get the language select. Here I'm not doing that. Here I'm just doing language select, then find elements beneath it, because language select is defined as a web element up here at the top. And we have annotated it with @findBy, and then the magic happens in the page object constructor. So in my constructor for my page object, I'm using a page factory to initialize the elements for this driver on this page object. So what this does is it looks through the object, finds any fields that are annotated with @findBy, then puts a proxy in place so that later on when I do a language select, it will lazily load and lazily find this web element. So I don't have to do a find element anymore because I've put the find by in the annotation on top of the web element, which can make my test class a little bit neater. So you see here in the IsLoaded, previously in IsLoaded, I did a driver.findElement by ID combo. Here you can see I'm basically just saying, is it displayed? If it's not displayed, then it won't be able to load it, and no such element exception will be thrown by the proxy object. We'll get the same effect. And down here, I'm just using category select on the assumption that it will find it through the proxy object and return a web element that we can use to carry on. So there is a lot of magic behind the scenes when you're using page object models in the page object factory. But all you really have to know is that we create web elements as fields in our page object. We annotate them with @findBy and explain how we can find this element. Then in the page object constructor or in your tests, somewhere down the line, you initialize the elements. Now that's the basics of the page object. In the next lecture, I'm going to go into it in a little bit more detail, but in order to not to overload you, the basics are we create our web elements as fields and we annotate them with @findBy, explaining how, and there's how ID, XPath, CSS selector, using, and this is what we would normally put in the find element by ID, with this as the ID. Then we make sure that we do a page factory.initElements for the class that we want to initialize. Now there's a bunch of different ways of initializing the elements, and we'll have a look at those in the next lecture. But to start using these, it's very simple. Single init elements and @findBy methods on the web element, then just use the web elements directly. So let's explore the page object factory in more detail. So you see that we annotated this web element called category select with how ID. Now if I have a look at the how class, you can see that I can do how. How do I find this? By name, by class name, in which case if it was by name, I'd put the name in here. If it was class name, I'd put the class name in the using. If it was by CSS selector, I'd put the CSS selector in here. And you can see all the different ways that we have of finding things. If I want to do how by XPath, how.xpath using, then the XPath statement will go in here. It's all very simple. Now what that lets us do is have a single place where we define the find element approach, and then we just use the web element later on. Now you can see down here in the page factory.initElements, let's drop into the code here. Well, let's have a look. Let's do a Control P here, and we can see that we can initialize the elements using the driver and the page object. We can also use an element locator factory. And what that lets us do is find it in different ways. So the default element locator factory, which comes when I just do init elements with the driver, doesn't do anything special to wait for the element. So it will lazily load the web element, but if it's not there, it will throw an element exception. We have other ways of doing this. So let's drop down into the code here. Now the reason I'm dropping down here is not so much to show you the page factory, although it's worth having a look through. All this really does is use reflection to build up the page objects. What I really want to show you down here was in the page factory itself, you can see that we have the default element locator factory. This is what is used with when I pass in the driver in the page object. It's a default element locator factory, which simply says use this element locator to find them. And if you look through the code here, this is very simple. It basically says Is it cached? Yes, return the cache. Otherwise, try and find it. There's nothing more complicated than that, which means it will lazily load it. Once it's loaded it, then it will return that back. We also have an Ajax element locator factory, which we instantiate with a timeout in seconds, because if the Ajax element locator cannot find it, it will wait. And it does that using a slow loading element in much the same way that we have the slow loadable component. We've got a slow loading element here, which, if we have a look through this, says, is it loaded? If not, loop around and try and find it again. So if we're using something where it's an Ajax, sometimes we would have to do waits in place in order to find it. Using an Ajax element locator factory allows you to build up page objects like this very simply, and instead of just saying init elements driver, if I say init elements new Ajax element locator factory driver, and then I say wait 20 seconds for the element, then when I try and find an element, if it can't find it, it will poll for that element for 20 seconds until it comes back. Now you can see the danger here. The danger here is we're now using a waiting pattern based on time that is not specific for each of the elements. So if I try and access the category select, but for whatever reason I'm on the wrong page or it doesn't exist, I will be waiting 20 seconds to find that problem. So we have to be careful with the page factory and using the different element locators. Now I think in production I've been moving away from the page object factories. I think page object factories are really useful for getting started really quickly. But I think that very often I need to have synchronization strategies that are unique for each element. So I tend to wrap things in methods. I do find elements down below and I will synchronize on each element. But it's worth being aware of and experimenting with the page object factory, because it can help you get started very quickly. You see here, if I was constructing this page, if I was doing it with page objects from the start, I would have known what the web element was. I've put it up here as a field. I would have just done the @find by. I would have simply started this with the driver. And my page code would have been a lot simpler, because I would just say this element dot do something to it, this element dot click. My abstraction there becomes very simple. So it can get you started very quickly. You can write your own custom locators and factory methods in order to find these elements and have the element locators done in a custom way, which I have had to do on occasion. But if you don't use page factories at all, then you don't need to create custom element locators. But it's worth being aware of the page object factory, simply because it might help you get started building a page object for your application very quickly. I just want to spend a couple of minutes showing you an approach that I've been using on slow loadable component page objects. Slow loadable component page objects are used for pages like this. You can see here that this page has a header and a form on it, but when the page loads, if I reload this, you can see that the header is there, then the form takes a little bit of time. Now if we don't add synchronization in our tests, we try and fill in the form or click the send button immediately, the test will fail because the elements aren't there. So we need to synchronize, and we use slow loadable components to do that. By the way, this page is public. It's an example from the QNES site, which just has a lot of examples and a lot of illustrations of web design work. And I thought this page was a really good example it's nice and simple, but it shows some of the synchronization problems that we have, and slow loadable component is a good fit for this. The source code for this, by the way, is all under the WebDriver experiments project, and the links are in a blog post, or you can see them here. Just go off to WebDriver experiments in the source test java.com Selenium simplified WebDriver slow loading, and you'll find all the page objects I'm using as examples in here. Now with a slow loadable component, we create the page object that extends slow loadable component, returning the page object itself, and we create a constructor that has the driver, uses the super to set it up, just the normal slow loadable component stuff. You can see here that this load method does actually load the page. Very often when I'm using slow loadable components, I don't load anything because they happen through navigation in an Ajax. And then we end up getting IsLoaded methods like this. All our IsLoaded methods tend to be wrapped with try-catch blocks because we have to catch WebDriver exceptions and convert them into errors, otherwise the slow loadable component doesn't pick them up. And then we end up having a very cluttered set of code in the IsLoaded, adding more and more try-catch blocks or more code in here with all the if-else in order to make the test work. And that's been annoying me recently, so what I've been doing instead is trying to make it a little bit cleaner. And I've been using an IsLoaded object for this. So it's a helper object. Now I kind of have an immediate aversion to helper objects because they tend to be dumping grounds where people just drop methods in. Like a page object helper method just has everything that anyone has ever intended to use with a generic page object methods. Here I don't mind it so much. This is really taking an example from the WebDriver ExpectedConditions class. That's a support object which has static methods that return expected conditions for WebDriver waits. It's really clean, it's a good example. This does the same thing. This is an IsLoaded helper, and you can see that it's fluent, it's readable. It says things like, this page is loaded, and it says is loaded when an element is visible, when an element is enabled, when another element is visible, when another element is enabled. And you can see I can just keep chaining methods on here that are in this IsLoaded class. And I've made it a little bit fluent with this for this method that takes the driver in. Now these methods, pretty much the same code as we had before, but just wrapped up in a nice, neat, tidy little package where there's a constructor in here. The for this is a public method that takes the constructor, so I don't need to use this factory method to construct it. I could construct it directly if I really wanted to. And we've got these when element is visible checks, which they're fluent in that they return this if it passes, so I can chain them, and they throw an error when they fail, which is captured by the slow loadable component. I think this is nice and tidy. I've been using this a lot in my production work for page objects. So try it out, experiment with it, see how you get on. Okay, I just want to spend a couple of minutes showing you a page object approach that I've been using recently. It's kind of a fluent page object approach where some of the methods on the page object return the page object itself. So you can see it in action here in this test. This is a test using a slow loadable page, and I'll show you why it's using a slow loadable component on this page. This is the page in question. You can see when I load it, when I refresh this, Control F5, so the page loads, and you can see the contact form isn't there immediately, so the send button isn't there immediately. So we need to do some synchronization on that. This was a really good example page that I found on the internet, and I'm just using this in this test. So here you can see I do the normal slow loadable component page thing. We get it, it synchronizes. Then, and this has nothing to do with slow loadable components, this is just a general page object thing. I use that page object, page 4. And then I'm setting the name and setting the email, setting the message and sending the message without having to use the page 4 object in there explicitly, because I'm just chaining these methods. And the way I do this is just by setting this method up so it returns a object that's the same type as the page object, and then just does a return this on here. So you can see we've got the normal page, extending slow loadable component, and the page method just returns the page. And that allows me in the test to chain it. And it's a pretty simple thing, but it allows your tests to be a bit more readable, a little bit more fluent, and gain more benefit from these page objects. Now this doesn't mean, I should be clear on this, that I return page objects from methods on the page object by default. Typically I don't, in the sense that I don't return other page objects from page object methods. like this send message, if when I click on send message it goes off to a message received page, I would not have the send message method return that received page, because I view that as a navigation, and I want the navigation I want more control in the tests for the navigation part, because I may type in all these details, the name, the email, the message, and there may be an error in here. And when I click send message, if there's an error, it may stay on the same page. And in those circumstances, we tend to end up creating things like send message expecting an error, which takes us back to the same page, and send message correctly, which returns a page object of the received page type. I think that's pretty ugly and clutters up the page, and I don't think the pages should be responsible for navigation. However, I do, on page methods, return child components. So if I modeled this form as a component on the page, so for instance here the page has a header, that might be a component, the contact form, that might be a component. I may choose to have a contact form object returned from my page 4 object, because that's a child, that's a component, that's a widget on that form, and then it seems valid to me to return it. So just a few words on page objects and using the return statement to return the page object to make your test a little bit more fluent.